Hello. So again, my name is Matthew Manowitz. I am a fourth year biology student at Algoma University, and I made I've made another tool now. This is I'm gonna call it in a series of procrastination. So previously, as you might remember or may not, I made a protein point mutation tool that allows you to easily just substitute amino acids, and it prints out your mutated FASTA to either be easily copied into AlphaFold or to be cataloged somewhere where you wish. So now, for a project I need to do, I was looking at how these mutations would then affect protein structures. So I decided to make a structure viewer. So as you can see here, I've called it mutate. I know, similar to the other, very awesome structure compare. So it's similar to the other one where you want to upload your wild type and you'll get a mutant one. So you want to download PDBs or CIF files will work as well. So in this example, I had a couple preloaded. So this is the protein SCN5A. I used it for previous projects, so it already has some mutations in it. And what happens is when you upload both of these files, it lets you focus in on one specific amino acid. So let's say, what residue might we want? Residue, maybe let's do 67. And from that point, you can just render panels, which down below here, you have wild type. It'll give you a full image of the protein, and then it'll zoom in on your specific residue. And then the mutant give you full, the entire protein, and then it'll zoom in on the specific residue on the mutant. So let's say the mutation occurred on the residue 67. We could do render panels plus root mean square deviation. So what that does, the root mean square deviation is kind of a number to show how closely similar structure-wise these two proteins are. So I thought that would just be kind of fun to throw in there because it's a quick eyeball. Like if you see root mean square deviations that are this small, you generally don't have any difference between the two proteins because there's just some variation between the AlphaFold models. Just some, they're not always going to be 100% perfect, but 0.029 of the global root mean square deviation, this is over the entire protein, and the local root mean square deviation of 0.03, that is this local window we see here. So that's root mean square deviation around just your focus residue. So you can get a little more specific if you want. So as we can see, this is a wild type protein here. It's an orange. That corresponds with the protein color here. And it's an RGB. You can change it whatever you want. I'll make it blue. And if you want it to be blue, you have to render panels again, and it'll be blue. And this is the highlight color. So this color is for your specific residue of interest. So this will be residue 67. So then we render, and now it's blue and highlights red. So this is the wild type. You can download the images individually. This is a mutant. As we can see, there's no difference. That's just because I didn't mutate these proteins, but they are different. That's why we have just some variation. And you can either download these four individually, or you can download them in a mosaic pattern. So let's zoom in here. You can also spin it, do however you want. Zoom in, spin it, do however you want. And let's download it in a mosaic. Great. So then it'll come here. We have our wild type full. We have our entire protein. And then we have the focus residue. Where was that? So this is the newest tool. I plan on using it. If you have any more questions, you can contact me via my email, matthewmanowitz@gmail.com. I didn't have any room for a smiley face. I couldn't get it to fit well. So this is what we got for now. Thank you.